Welcome to a brand new deep dive. We're calling this one Cosmic Boundaries, the Infinity Paradox, and I am absolutely thrilled you're here today. We are going to jump straight into exploring the sheer, mind-bending scale of the universe itself. We're tackling some of the absolute biggest questions humanity has ever asked, and we're going to use real data and some truly fascinating thought experiments to do it. So if you've ever looked up at the night sky and felt that overwhelming sense of awe and maybe just a little bit of existential vertigo, you are in exactly the right place. We are going to stretch our brains to the absolute limit today. Let's get into it.
So, does the universe have an edge? I mean, it sounds like a simple yes or no question, doesn't it? But really think about it for a second. If there is an edge, what does it look like? If you could somehow build a spaceship capable of traveling as far as physically possible in one straight line, what would you actually see when you got there? Is there a literal wall? A drop-off into nothingness? To answer this properly, we need to ground ourselves in some concrete data first.
Okay, let's kick this off with our first hard number, 13.8 billion. Today we know for an absolute fact that the universe had a definitive beginning roughly 13.8 billion years ago. And ever since that spectacular moment, it has been continuously expanding outward. Now, basic logic would tell us that something that's been expanding for a set amount of time must have a boundary, right? Because information, which includes light, cannot travel faster than the speed of light. We can only see parts of the universe whose light has actually had enough time to reach us over those 13.8 billion years.
But wait, there's a catch. The universe hasn't just been sitting perfectly still, it's been expanding this entire time. Because of this ongoing cosmic expansion, the most faraway objects whose light we can currently see aren't just 13.8 billion light-years away anymore, they've actually been carried outward by the expansion of space itself. So right now, those furthest objects are sitting about 46.5 billion light-years away from us in every single direction. That makes our visible bubble a sphere with a massive radius of 46.5 billion light-years.
And to cap off these rapid-fire numbers, let's talk about 200 billion. Inside that massive 46.5 billion light-year radius, there are roughly 200 billion galaxies. And remember, every single one of those galaxies contains hundreds of billions of stars. It's almost impossible for the human brain to comprehend that scale, but this sets the exact size and contents of the visible bubble that you and I are sitting inside right now.
So, the crucial takeaway here is this. We call this bubble the observable universe. It's a spherical region perfectly centered on us. But pay close attention to that definition. For us, there is an edge, sure, but it is not a physical wall. We are literally looking into the past until there is just no past left to see. This boundary is actually an edge in time. In a physical sense, an edge in time is kind of meaningless because we know the real universe is definitely bigger than what we can see. The billion-dollar question is, how much bigger?
Let's see how this builds into our first major theoretical option, a finite universe. I love to think about this through the finite ice cream problem. If the universe is finite, it means that if you wanted to fill the entire thing with ice cream, you could physically do it. You need a ridiculous amount of ice cream, obviously, but it would be a finite amount. But this creates a huge paradox. A finite universe implies an edge, a literal cosmic wall where space just ends. And if space ends, well, what's outside of it? The universe is defined as all there is, so you can't have stuff outside of everything. So how do we solve this?
Picture a tiny ant crawling on an orange. From the ant's perspective, it only sees a really small chunk of the skin, right? Just like we only see our observable chunk of the universe. But if that ant starts walking in a perfectly straight line, it's never going to hit an edge or a wall. Eventually, it will just walk all the way around the orange and end up right back exactly where it started. The surface of the orange is completely finite. You could easily cover it in a finite amount of ice cream, but it has absolutely no border.
Now, the universe obviously isn't the 2D skin of an orange, but it could act in a very similar way. Enter the hypersphere. Basically, this is a model where our entire 3D space is curled back in on itself. Now, I know it is virtually impossible for the human brain to visualize a 3D space folding like that, but the physics really boils down to gravity. Mass creates gravity by bending space-time, and this bending stretches on forever, kind of like a mild tension in the fabric of reality. This tension could bend the whole universe back on itself. So in this hypersphere, there are zero borders, and absolutely no outside. If you flew a spaceship in a straight line for long enough, you'd eventually approach Earth from the exact opposite direction.
Now, you might be wondering, if we do live in a hypersphere, shouldn't we be able to see the curve? On Earth, we can calculate the planet's size just by watching ships disappear over the horizon. Scientists have actually scoured the cosmos, looking for a similar universe horizon, but they haven't found a single trace of one. Because we don't see a curve, if the universe is a hypersphere, it must be so incredibly gargantuan that from our tiny perspective, it looks perfectly flat.
Mathematically, it would have to be a minimum of 1,000 times bigger than our observable universe. I mean, it could be 1,000,000,000,000 times bigger, but at the very least, 1,000 times. But some scientists took that idea and decided it was just a little too straightforward. So they proposed an even wilder option, the hyperdonut. Notice the strange geometry here. A hypersphere is totally symmetric. It doesn't matter which way you fly your spaceship, it will take the exact same amount of time to circumnavigate the universe and return home. But a hyperdonut is entirely asymmetric. There isn't the same amount of stuff or space in every direction. If two ships fly out in completely different directions, one of them could loop the entire universe and get back to the start way earlier than the other. Because of this strange asymmetric geometry, light traveling from faraway galaxies would do some incredibly confusing things. It basically creates a cosmic hall of mirrors effect. You wouldn't just see the same faraway object in two different places in the sky. Because light would take much longer to travel one path around the donut than the other, you would actually see that exact same object at two completely different moments in time. You could literally look in one direction and watch a new star being born, and then look in the opposite direction and watch that exact same star die simultaneously. It is an absolutely beautiful and totally mind-bending concept. Okay, so much for the finite options. Let's pivot our analysis entirely. What if the universe isn't a hypersphere or a hyperdonut? What if it's truly infinite, and space simply goes on forever with no borders, no curving back on itself, just endless reality? Believe it or not, this is actually the cosmological model favored by most scientists today. We usually just use this model to calculate what happens inside our local observable chunk, but if you take the math literally, it predicts an unending, infinite universe. But this immediately introduces a glaring paradox. We already established that the universe started with the Big Bang and is expanding. So how on earth can an infinite thing that is already everywhere become even bigger? It bends the mind for sure, but cosmic expansion doesn't mean the universe is growing into some empty void. Expansion simply means that the physical distance between the galaxies within the space is growing over time. The space itself is stretching. So yes, even a truly infinite space can become bigger. Welcome to the crazy paradoxes of infinity. And infinity gets so much weirder than that. Let's walk through this three-step logic together. Step 1. Everything in existence, every planet, star, and person, is made from a finite set of fundamental particles. Step 2. A finite number of particles can only be arranged in a finite number of combinations. Yes, the number of possible combinations is so unimaginably huge that it feels like infinity to our brains, but mathematically, it is finite. Step 3. If you take those finite combination options and you place them inside a space that goes on endlessly forever, it guarantees that by pure random chance, those combinations must eventually start repeating. Which brings us to this staggering quote directly from our source material. If you travel fast enough and far enough past new galaxies, alien life forms, and strange wonders, eventually, quote, you might find the most special thing in the universe, yourself. An exact copy of you watching this exact analysis right now. Think about the philosophical weight of that. If the laws of physics are the same everywhere, then far enough away, the exact same chemistry emerged, the exact same evolution occurred, and an exact replica of you is sitting there experiencing this exact same moment. Now, I know you're wondering just how far you'd have to travel to actually knock on the door of this identical you. Well, here is the math. It is 10 to the power of 10 to the power of 29 times the size of our observable universe. That is a double exponential, a 1 followed by 100 octillion zeros. Just let that visually imposing number sink in for a second. The chance of Earth existing exactly as it does is so vanishingly small that the distance required for the particles to randomly arrange exactly like this again is so incredibly large, it basically just means forever far away. You will unfortunately never get to meet them. All right, let's all take a collective deep breath. Let's ground ourselves back in reality here. All of these concepts, the hypersphere, the hyperdonut, the infinite repeating Earths, they are incredibly fun to think about, but they are currently untestable. We have firmly crossed the border from hard astrophysics into science philosophy. If the universe truly is infinite, we will simply never be able to prove it. For all practical intents and purposes, our reality remains safely bounded by that edge in time we discussed earlier. We are limited to our observable bubble, and most likely that's going to stay true forever. But please, don't let the fact that our observable universe is just a tiny fraction of total reality make you feel small or trapped. There is infinitely enough for all of us.
Even if our finite bubble feels restrictive compared to true infinity, it still contains 200 billion galaxies. It contains more wonders, mysteries, and sheer beauty than we or any of our descendants could ever possibly hope to explore or understand. It is more than enough to fulfill every single dream humanity can dream up.
Which brings us to our final thought for today. We know we are bound by an edge in time, looking out into the deep past. But I want to leave you with this question. What impossible wonders might be waiting just a few light years beyond our visible horizon? What realities exist right outside that bubble of light? It's a thought that keeps me gazing up at the stars at night, absolutely fascinated by the fine line between everything we can know and everything we never will. Thank you so much for joining me to explore the edges of reality today. Keep questioning, keep looking up, and I will see you in the next one.